All right, hi everyone. So we're going to move on to looking at quadratics now. So, we're still technically looking at functions because quadratics are a function. But we're going to look back and for this little bit of a topic, we are going to need some of those skills, not so much today, but from kind of Saturday, next Tuesday. Some of those skills that we did right at the start of the year, so things like factorising, quadratic formula, completing the square, they're all going to come back into play again now, and we are going to spend quite a bit of time doing this. Okay, now today's lesson is not going to be very long or particularly difficult. So I expect that a lot of you will finish this, within half an hour. That's completely fine. And instead of getting you to do extra work on top of that just to fill up the time, I'd rather maybe you go through and you look at some of those things, go back, refresh, look at your notes on completing the square or quadratic formula, anything like that. But I don't think there's much point, making busy work for you or trying to put too much stuff in at the moment. And that gives people who maybe might be finding it more difficult the opportunity to ask questions and to get in touch if they do need any extra help. Okay, so this should be pretty easy today. The first thing we want to talk about, well, in terms of plotting quadratics, first thing we need to know about, and this is the same with plotting all graphs, what's the difference between plotting and sketching? Because they are quite different. So if you get a question in, say, an exam or whatever, or even just, in a textbook or in your research, you might be asked to plot a graph or to sketch a graph, and they mean two quite different things. So when we're talking about plotting, we're meaning having exact coordinates. Okay, and you might plot a set of coordinates. You're probably not going to plot all coordinates because I remember a lot of our functions have infinite domains, so you're not going to plot all of them. But you're definitely looking at plotting exact coordinates or exact points. Now, when you're sketching, you can sketch a graph by just using the main points of interest. And as long as those are correct, all of the individual points don't all have to be perfect, okay, as long as you've got the main shape of what you're looking at. So when we're talking about main points of interest, we're talking about things like x-intercepts, y-intercepts. Okay, with quadratics, we're looking at something very specific called a turning point. Okay, and there's some of the things that you might be looking for. There are more things than that, but for the moment they're really the only ones you have to worry about. Okay, so we're going to jump straight into one of the hardest ones because you guys are amazing and you should be fine with doing it. So we're looking at we're plotting the graph of the quadratic function f of x equals x squared plus 3x minus 4, and we're using this table. So because we're plotting, we want all of these points. And we're going to use these ones to help you. Now, some of these might actually go off the graph and off the grid, and if they do, we just won't plot them. Okay, because I just copied and pasted a random grid off the internet. So for this first one, we're looking at -5. So f of -5. Okay, remembering we're using all the proper notation now. We can sub that -5 in for our equation. So we've got -5 squared plus 3 times -5 minus 4. Now, if you want, you can just chuck that in your calculator. I haven't got mine on hand, so I'm going to say that's 25 minus 15 minus 4. Okay, so that's 10 minus 4 gives me 6. Okay, so my f of -5 is 6. Right. The next one we're going to look at is f of -4. Alright, so f of -4, we do the same thing again, but we're subbing in -4. So we've got -4 squared plus 3 times -4 minus 4. So 16 minus 12 minus 4, okay, and that's 0. So we have a y coordinate of 0 there. Okay, f of -3, we've got -3 all squared minus plus 3 times -3 minus, what am I doing? Minus 4. Okay, so that's 9 minus 9 minus 4, okay, which is -4. I'll chuck that one in there. F of -2, -2 squared plus 3 times -2 minus 4. Okay, so that is 4 minus 6 minus 4, so that's negative 6. Okay, and then just give me a second, I'm just going to rub this out. We'll go on to do the next ones. Now we're not going to do, don't worry, we're not going to do all of these, but we are just going to do a certain amount, just so I can kind of prove a point to you that it's going to help, and it's going to come into play a lot when we're doing the sketching. Okay, so we're not going to go through and work all of these out, but we are going to do quite a few. Okay, so the next one, f of negative 1, okay, is negative 1 squared plus 3 times negative 1 minus 4. So 1 minus 3 minus 4, negative 7 minus 1, so that's negative 6 again. Let me check. 1 minus 7, yep, negative 6. Okay, now 0, f of 0, nice and easy, 0 squared plus 3 times 0 minus 4, so that's negative 4. Now what you should see here is that we're starting to repeat that pattern, and we might actually be going through and doing all of these actually now looking at it. Okay, now so I'm going to make the conjecture. So see, we've gone from 6, 0, negative 4, negative 6. Now we're going back to negative 6, negative 4. Now we're going back. I reckon this one's going to be 0 again. Okay, so that's f of 1 is 1 squared plus 3 times 1 minus 4. Okay, so that's 1 plus 3 minus 4. Okay, 1 plus 3 is 4, minus 4 is 0. So back at 0 again. All right. Now the next one, that one's definitely going to be 6. I can tell you that for sure. We're not going to work this one out. So that one's 6, because again, we're repeating our pattern. Now we have to work out 3. So f of 3, because we don't have a repeating one for that. So that's 3 squared plus 3 times 3 minus 4. So 9 plus 9 minus 4. 18 minus 4 is 14. So that one's going to go there. Okay, and now we're actually going to leave these ones here, and we're not going to plot those because they don't fit on our grid that we have here. Okay, so we're just going to plot from negative 5 to 2. If we wanted to, we could have kept going up, but we need more space on this grid. Okay, so now we're going to go through and we're going to plot it. So we find negative 5 and 6, and we're going to put in a point there. Okay, so that's that first point there where we've got x is negative 5, f of x is 6. Next one's at negative 4, 0. Okay, so that's on the axis down at 0. Next one is negative 3, negative 4. So that's that one there. Next one's negative 2, 6. Okay, next one is negative 1, 6. And the next one at 0, we're back at negative 4. Then at 1, we're back at 0. And then at 2, we're back at 6. Okay, so that's the start of what our quadratic would look like. Our next point, which we worked out, was 3, 14, so that would have been, somewhere up here. And likewise, negative 6, that would have also given us a value of 14, somewhere up there. Okay, so the next thing is we need to join this up so we can see the shape of our function. So I'm just going to use another colour. Use orange. Actually, no, orange is going to look too the same. We'll use green. Okay, so we're going to go through and we're going to join these up. Ooh. You should be able to do a better job of this than I can because I'm trying to look at the computer. Right. Okay, I'm just going to show that it keeps going. Cool, there we go. So you'll notice here, something really important is that I've made a point go lower than negative 6. Now that's because in any quadratic, there's always one single lowest point on the function, and that's what we call the turning point. It's the point where it flips around and it goes back in the opposite direction, but there's always one point that is the lowest. So I could work that out here because I had 2 points that were both negative 6 and then it started to increase again. I could work out that that means that between that negative 2 and negative 1 there must be a point that was lower than both of those. And now if I put that in, if I do negative 1.5, okay, and I do 1.5 squared plus 3 lots of, negative 1.5, 3 lots of negative 1.5 minus 4, and I work that out. I'm just going to be lazy and use my calculator. Okay, I get negative 6.25 as an answer. Okay, so that's lower down than both of those -6s. So there must have been one point in between here that's lower than both of those. So I've just showed that as a little dip in between them. Okay, that's really important. Now, a couple of features, again, that come up when we're looking at sketching are intercepts. Okay, and also with quadratics, we have, like I said, this kind of line of symmetry in between it. So again, I'm just going to change the color of my pen. So in this case, our x-intercepts, okay, there's one here at -4. Okay, there's one here at +1. Okay, -4 there, that's your y-intercept. Okay, when x is 0. And these two are both where y is 0. You should be able to see that. You've got 0 as your f of x. Okay, and likewise your x-intercept is where x is 0. And you've got that y value. And then the last thing is with a quadratic, you have this special line, which is the line about which the graph is symmetrical, which is what we call our axis of symmetry. Okay, so in this case, it would be about -1.5. And it's called our axis of symmetry. Okay, x equals -1.5. All right, I'm just going to do one more example. If you think you've got it from this point onwards, then just jump through, do the work. I couldn't do a Google Forms for this one because obviously there's a lot of plotting, so you have to be able to do it by hand. So the sheet is attached. If you would like another example, just hold tight and we'll do one in a second. Okay, so next one, really quickly, we're going to look at f of x equals -x² minus 2x. So with this one, we're only looking at values between -3 and 3. And that's all you're asked to plot for, and so we're going to use that. So we're going to start off with f of -3, okay, which is -3² minus 2 times -3. Okay, now you got essentially 3 negatives there, so that's still going to come out as negative because the -3² gives you +9, but then you've got +9, so it's -9, okay, plus 6, okay, which is -3. Okay, f of -2, -2 minus 2 times -2. Okay, I've written that in a weird way, and so that should have a squared. So -2 all squared negative is -4. And then -2 times -2 is +4. Okay, so that's 0 there. All right. Next one, f of -1. It's -1 all squared minus 2 times -1. So you've got -1 plus 2, so that's +1. Okay, at 0, f of 0 equals -0, which is just 0, obviously, minus 2 times 0, which is 0, so that's there. Okay, f of 1 is 1 squared, -1 squared, minus 2 times 1. -1 squared is 1, minus 2, so that's -3. Okay, f of 2, that's -2 all squared minus 2 times 2. So -4 minus 4 is -8. Right, and last one, I think this one's going to go off the screen as well. F of 3, -3 squared minus 2 times 3. So that's -9 minus 6. Yes, which is -15, so that one's not going to work, so we'll cancel that one out too. Okay, so now we can go through and plot this. So here we've got, now what you'll notice with this one, a little bit different, is that we've actually got a biggest value, not a smallest value. It's still a turning point because it still reaches what we call a maximal condition and then it turns around, but it's a maximum, not a minimum. Okay, so that's at -1, -1, so that's there. Okay, then we have -2, 0 and 0, 0. Okay, there are our intercepts. We have we have 1, -3 and -3, -3. And we also have 2, -8, and I'll put that one too. And then we're just going to join up the points. And voila, there we go, there's our plotted graph. Okay, go and have a go at that worksheet now. Contact me if you have any problems. Okay? All right, bye.